All right, so good day everyone. So we are now once again in this next lesson that we have in physics, and this time in this lesson that we will have, we will going to talk about reflection, because one of the important application of this topic that we have right here is how mirrors tend to form images. All right, so one of those process is called reflection. All right, so let's get this over with. Okay, so the key question that we were going to answer here is, how do we describe the reflection of light? All right, so in the process of reflection, how can we say that the light is being reflected? And then when the light is reflected, what happens to its angle? Yeah, so that is the thing that we were going to discover in this particular session. All right, and the objective of this particular lesson is for us to compute somehow the angles of reflection for a single ray of light. All right, so we will compute, and at the same time we will demonstrate how light is being reflected on any kind of surface. All right, so that is reflection. Okay, so let's start. Now, we are now in the branch of physics that deals with the application of light and how they can be utilized. So this particular branch is called optics, right? So optics is the study on how the light behaves. So we will discover here, or in this particular lesson that we have, so not only in reflection but also in the next lesson that we will have in the future, which is the mirror. So we will study there how light behaves on those instances. Alright, so we will explaining how magnification occurs is part of the science of optics. Alright, so optics is also the reason why objects which is small becomes magnified, and objects that are far can be magnified or can be seen using different instruments and different mirrors and lenses. All right, next one. All right, so the diagrams of light use one or more imaginary lines called light rays. So in this particular part of this lesson, we will also use diagrams of light called ray diagram in order to find out how the image is formed using different mirrors and lenses. Right? So there we go. Okay, next one. Okay. A ray diagram is an accurately drawn sketch showing how light rays interacts with mirror, lenses, and other optical devices. So we will work on this in the future discussion that we will have. But for now, I will introduce to you to how person who is expert in optics be able to analyze how light behaves. Alright, so to be able to analyze that one, they use a certain diagram or a certain technique called ray diagram to sketch how light rays behaves at any instances. Alright, so now we'll enter now to one process on how light rays behaves. This is the part called reflection and refraction. All right, so there are some objects that used to bend. All right, they used to bend light in a specific way. So therefore, these objects tend to refract light. Alright, so the moment it enters to this particular object. So these are called lenses. Yeah. So they tend to bend the light in a certain way. Now, there are two types of lenses. So we have here the converging lens and the diverging lens. Alright, so later on the next videos that we will have, we will try to discover what is the difference between these lenses that we have right here. Alright, so aside from lenses, we have here the mirrors. Also, the mirrors are objects that manipulates or that exploit the behavior of light. So mirrors, if lenses bends the light, the mirrors reflects them in other ways. All right. So one of them All right, one example of an optical device here that we that causes the light to change direction is called the prism. Yan, prism is a solid piece of glass with flat polished surfaces. All right, so a prism looks like the one that we have right here. So we'll turn on our pen. All right, so this is a Alright, so this is a typical prism. So if you know a prism, it looks like this, right? So there's this the mirror, and we have there the converging lens and then the diverging lens. Altogether, these four try to manipulate or try to exploit how light behaves when it enters to these particular objects. Alright, so what is reflection? Now, reflection occurs, this is a process which occurs when light bounces off. So, please take note that when the light bounces off at any surface, yan, so, okay, when light bounces off on any surface, okay, and not only bounces off, when the light bends while crossing through material, so when they bend, alright, while crossing through any kind of material, this is what they call reflection. Alright, so not only like that. Okay, so I will clarify myself. Alright, so when the light bounces off, that is reflection. When the light bends, this is now your refraction. Right, so that is refraction. Okay, so light bends, refraction, light bounces off, reflection. Alright, so next one. Alright, so what is a reflection? So when a light reflects on any surface, images likely to appear in this particular surface. Alright, example here we have the mirror. When the mirror or when light passes through a mirror and it bounces off the mirror, it forms a certain images. Then therefore, the image that is formed is a product of how light is being reflected through the mirror. Alright, so what do we have right here? Okay, we have right here some alright, so we have right here some rays that you should take note of with studying reflection and refraction. Alright, so the first ray that goes on any surface, we called it the incident ray. Now in this case, mirror or in reflection, there's an incident ray. So the incident ray that we have right here is the one that goes on the mirror. Alright, so this is the incident ray. Alright, so this the ray that goes on through the mirror or onto the mirror is called the incident ray. And the one that bounces off the mirror is this is the reflected ray. Alright, so yan. So in reflection, there are two rays of light: the incident ray, the ray that the light that goes onto the mirror, and the reflected ray, the light that bounces off the surface of the mirror. All right, next. All right. So if the surface is not smooth, okay. So or if the surface is smooth, so what happens is a single ray of light, like the one that we have right here, if the surface is smooth, okay, so if the surface is smooth, the single ray of light will bounce off in a single direction. So as you can see, it approaches the mirror in single direction and it leaves the mirror at a one direction, towards one direction. Alright. Meanwhile, if the surface is not shiny, or should I say rough, if the surface is rough, there is what they call diffuse reflection. Okay, so how does diffuse reflection differs from specular reflection? Now, the diffuse reflections from a single ray of light, it scatters into many directions. Thus, there will the number of reflected rays are scattered in too many directions. So that the one that we have right here. That's the reason why we be able to appreciate how smooth the object is and how rough the objects are. Alright, so yeah, rough objects do diffuse reflection, and smooth surfaces or smooth objects like the mirrors do specular reflections. Alright, next one. Alright, the reflection process follows a certain rule. Alright, so we have right here the law of reflection. Now, what does this rule tell us? It tells us that the angle of incidence, so the incident ray, is equal to the angle of reflection. So it means that the reflected ray should, it follows the rule, should be equal to the incident ray or vice versa. And with regards to that, if the light passes through that particular mirror, then if it follows the law of reflection, it should have an equal angle of incident and angle of reflection. Okay, so yeah, okay, so that's how your law of reflection works in mirrors. Yeah, okay, so in an actual experiment, alright, so in an actual experiment, the incident ray strikes the mirror, and then the reflected ray is bounced off. Yeah, and technically, as what the law of reflection says, the angle of incidence should be equal to angle of reflection. Alright, so the way that we have right here. So meaning to say that if the angle of incidence is 30, or if the angle of incidence is 25 degrees, so the angle of reflection so will be 25 degrees as well. So they should be equal. Okay. So alright, so let's try out some sample problem with regards to some law of reflection. Alright, so example, a light ray is the light ray is incident to the plane mirror. So meaning to say, a light ray is incoming or going through the mirror in a 30-degree angle of incidence. Alright, so we have here the 30. Alright, so the 30-degree angle of incidence. Alright, so now sketch the incident and reflected rays and determine the angle of reflection. So even though alright, so even though we don't have any more we don't need to do the sketch anymore. If you remember what the law of reflection states that the angle of incidence must be equal to the angle of reflection. So if the angle of incidence is 30 degrees, so what do you expect? The angle of reflection, alright, so the angle of reflection should be also 30 degrees. Okay, so that's how the law of reflection works. Okay, so you have right here 30 and 30 degrees respectively. Alright, so basically that is the law, or that is how the process of reflection, works. Alright, to see better view or to see more demonstration about reflection, so let's go to the simulator. Alright, so suppose that the light is coming this particular direction. Right, so what we will do here is we will try to shift down the light that we have right here. Alright, so here we go. Okay, so alright, let's use some sort of a green light, or red light. Yeah. It's hard to see. Alright, so yellow light. Now let's see if the law of reflection works here on the simulator. Alright, so we will pull off one of the protractor here and place it on the vertex of that angle. So let's see. Now as I pull down this this angle to the angle of the light that we have right here, so it says that the angle of incidence, the one that we have right here, it says that it is 17 degrees. Alright, so now let's measure the angle of reflection. Alright, so again we put that on we put this protractor on the vertex of that angle, and then pull the angle pull this down to the point where the light reflects. Alright, so we have right here. Alright, so Okay, so what we have right here is a clear demonstration on how the law of reflection works. So it means that the angle of incidence is equal to the angle of reflection rather. Alright, so I hope you did learn something on this video. Right, so if you have questions, don't forget to write on the comment section. Alright, so that's it. And don't forget to smile, alright, and we'll see you next time on the next lesson. Alright, goodbye.